This is lesson 58 for course 1, probability and chance. So we're going to start off with this type of thing. So what you're looking at here is a chart that's just really simply showing the chance of something happening. So if your chance is 0, your chance is certain not to occur or absolutely not going to happen. Okay? Halfway or 50%, you're looking at 0 to 50%, it's unlikely. Okay, it gets less likely as the number gets bigger, but it's still unlikely if it's below half. Once you get above half, it's referred to as likely to occur. So it is more likely to occur than it was before. If you get all the way to 1 or your final number, you are certain to occur. So this is absolutely positively going to happen. Okay, just remember that those little things, certain not to occur, unlikely, likely once you pass halfway, and certain to occur. Now, when you're looking at probability, there is a new thing we call sample space. So sample space is really just saying what you're working with. So for example, if you had a coin and you said you were going to flip the coin once, you would have a sample space of heads and tails, because you have a 50-50 chance of either getting heads or tails. Okay, because if you flip a coin, there is an equal amount of probability of you getting either way. So it's a 50-50 chance or a 1-to-1. Okay. This is your sample space, heads or tails. That is what you're going to get. Okay, now if I said you were going to do it twice, that you were going to flip the coin 2 times, your sample space would change. Because now what you're looking at is every outcome you could have if you flipped it twice. So if you flipped it twice, you could get heads twice. You could get heads and then tails. You could get tails twice, or you can get tails and then heads. That is the sample space for flipping the coin twice. Okay, you go from flipping it once, you can just either get heads or tails. If you flip it twice, you can do double heads, heads then tails, tails and tails, or tails then heads. So this sample space, because I'm now flipping the coin twice, is bigger than this one. But that is your sample space. You're looking at the odds of getting each thing. And because the odds of getting all of these are the exact same, that's why they're written this way. Okay, next thing is we're going to look at a circle. So we have A, B, and C, and this is a spinner. So the idea is if you flick the spinner, what would you land on and what's the chance of you landing on each one? Okay, well, the chance of you landing on A is half, or 50%. Okay, or if you're looking at decimals, it would be 0.5. Okay, that is the chance of you landing on A, because A is half of the circle. So there is a 50% chance. Now, if you notice, B and C are not half of the circle. B and C are actually the exact same. They are a quarter of the circle. Okay, and if you're looking at a quarter, you're looking at 25%, which is 0.25 or 25 hundredths. Okay, now I know this is correct because if I were to add up all of my percentages, I should get 100%. And I do, which tells me I have now accounted for 100% of the circle. So out of the 100% of a circle, I have a 50% chance of getting A, 25% chance of getting C, and 25% chance of getting B. Okay, or I get half of a chance, or one in 2 chances, 1 in 4, 1 in 4. Okay, that's another way of looking at it. I have a 1 in 2 chance of getting A, I have a 1 in 4 chance of getting B, I have a 1 in 4 chance of getting C. Or my decimals, 5, 0.5, 0.25, 0.25. So let's look at another one. So we're going to use this spinner, and it's saying that Meredith is spinning the spinner 28 times. Okay, so she spun it 28 times. About how many times can she expect the spinner to land on the sector A? So remember what we said, A equals half. So if this is a perfect world and it goes exactly how it should, okay, you will land on A exactly half of the time, which means we look at 28 and we divide by 2 to get half. What is half of 28? Well, half of 28 is 14. Okay, so she will get 14, or A, 14 times. Okay, if she spins 28 times. Now, we also have to answer this for B and C. So B, remember, was 1/4. So you would then take 28 and divide it by 4 to get the quarter. Or you can just look at 14 and go, okay, well, I know 14 is half of 28. So if I half 14, I will get a quarter of 28, because a quarter is half of a half. So I'm going to half the half. 14, half of 14 is 7. And C, because it is the same, is 7. Now, I should know that this is correct because I should be able to add all of these together and get 28, which I can. So if she were to spin the spinner 28 times, she would land on A 14 times, B 7 times, and C 7 times. Because A is half, which is 14, B is a quarter, 7, and C is a quarter, 7. What this means is because this is half, she is more likely to land on A. She is unlikely to land on B or C, or at least less likely to land on B, or to land on B, and she is less likely to land on C. Okay, next one. A weather forecaster says that there is a 60% chance of rain tomorrow. So we have 60% chance of rain. Okay. Find the probability that it will rain tomorrow. How I do this is I turn 60 into a fraction, which is 60 over 100. I then need to put it into lowest terms. So I'm going to take my 60 over 100. I'm going to divide both of those numbers by a number that will take it down. Let's say 10. I know 10 will take both those numbers down. 10 equals 60 divided by 10 is 6. 100 divided by 10 is 10. I can take that farther. So let's now divide by 2, because both of those are even. 6 divided by 2 is 3. 10 divided by 2 is 5. I can't take those numbers any farther. So you have a 3/5 chance of it raining tomorrow. Okay, according to this. Or A, because again, 60 over 100, if you were changing it into a decimal, you'd have a 0.6 chance of it raining. Okay, because remember, it's actually this, 60 hundredths, but because we don't need that 0 at the end, we can just erase that. So you either have a 3/5 chance of it raining tomorrow or a 6/10 chance of it raining tomorrow. Now, what if we wanted to do the opposite? What if we go, okay, well, wait a minute. We know that it is 60% chance it's going to rain tomorrow. So it is likely that it will rain tomorrow because 60% is over half. What if we wanted to know the chance of it not raining tomorrow? Well, if there's a 60% chance that it's going to rain, what you are now looking for is the complement of the event. The complement is the exact opposite. So 60% going to rain. The complement is not going to rain. So if 60% is going to rain, we need to know what percent is not going to rain, or what the complement event is. Okay, how we do that is we take our number 60, and we learned that 60, okay, was actually 6/10 when we did that before. Remember when we took it down before 3/5? We're going to take that away from 1. Okay, now what we do is we need to understand that 1 is actually 10 over 10. Okay, so 10 over 10, take away 6/10 equals 4/10. Because remember, this is 10 over 10 because we want same denominator. Okay, so 10 over 10, take away 6/10 is 4/10. 4/10 made smaller, divide by 2, simplify, is 2 over 5. So you have 2/5 of a chance that it is not going to rain tomorrow, or 4/10 of a chance that it will not rain tomorrow, or a 40% chance that it will not rain tomorrow. That is the complement event, the exact opposite. That's what the complement event is the exact opposite of what we said is going to happen. If we said it is going to rain, the complement is that it is not going to rain. What is the chance? So it is unlikely that it will not rain tomorrow. It is likely that it will rain tomorrow, according to these statistics. Okay, let's do it one more time. A number cube is rolled, so a number cube is a die. Find the probability that the upturned number is greater than 4. So first of all, your sample space. So your sample space for a number cube, if you're just rolling it once, is 1, 2, 3, 4, 5, 6. That is your sample space. Okay, it is, you have an equal probability of getting any one of those numbers if you roll the die once. So you have an equal chance. So how many of these numbers are greater than 4? Well, 5 and 6 are greater than 4. So if I'm looking for what is greater than 4, there are 2 of these 6 probabilities is greater than 4. Okay, I have 6 numbers altogether. 2 of them are greater than 4. So I have 2 over 6. Now I can make that into lowest terms. So I'm going to divide this by 2, divide this by 2, which is going to give me 1 over 3. Okay, so you have 1 in 3 chances of getting a number larger than 4. Now, what if I wanted a number smaller than 4? Well, there are 1, 2, 3 numbers smaller than 4. So let's do this one. There are 3 numbers of the 6 that are smaller than 4. Make this smaller, divide by 3, divide by 3. This gives me 1 over 2. Okay, so I have a 1 in 2 chance of getting a number smaller than 4. Which one is a better probability? 1 in 3 or 1 in 2? 1 in 2. Okay, because basically what this is saying is that if I rolled the dice 3 times, at least one of them should be bigger than 4. If I rolled the dice 2 times, at least one of them should be less than 4. So this is better odds. If you were, for example, betting on this, you'd want to bet on this one because you are more likely to get a number smaller than 4 than you are to get a number bigger than 4. That is Probability and Chance Lesson 58 for Course 1.